Welcome to the Week 1 live session. This is MAT0020 Beginning Algebra. And what I'll do in this first live session is talk about how the class is set up a little bit, what kind of assignments you'll have, and then I'll go over some problems and concepts that you'll see this week. So in the assignments each week are, some of it is consistent. So we have only 4 weeks. Each week we have a quiz, a test, and then bonus points. So we have that this week, but we also have, excuse me, some extra things here. We also have pre-test certification, quiz, and tests. We have a bunch of this stuff too. So the live session is where I'm doing this video, and I'll play this during the live session, or I'll just give you the link depending on what's going on. You have an intro discussion. This isn't for a grade. You also have these 2 discussions you can participate in, and there's this live session. There's a lot for week 1, pre-test certification, quiz, test. So you can always go in the grade book and look at what's due, like what's required. You can always look in the grade book of any course to see what's required, because if it's for a grade, if it's required, it'll be in the grade book. If it's somewhere else in the course and you see it, it's just extra. As far as the bonus points, you'll see the bonus points column in the grade book. So the way you can get bonus points is participate in the main discussion and or the summary discussion. Each week we have two types of discussions, and or you can attend the live session and or watch the recording. Any one of these things is fine with me. I go and look after the weekends to see who did what, and I just add the points into the grade book according to that. I wanted to give you a difference between the quizzes and the tests. The quizzes and tests are taken through Blackboard, so the problems are within Blackboard, and there's a database of problems, so the quiz and test draw from that database, and when I create my live session slides, I look at the quizzes and the tests so I can help you prepare for those. And I also created some list of problems in my math lab according to that. So the quiz and the test are each 25 questions. They're each multiple choice. For the quiz, you have unlimited number of attempts. For the test, you only have 1 attempt. No calculators really allowed for either. There's no clock for the quiz. And then for the test, you get 3 hours, but nobody's ever needed that much at all. There's never been a time issue. But the key thing I want to emphasize is this unlimited number of attempts for the quiz. So this is like a rare opportunity in college, and you want to grab up every point you can in college. That's the way to attempt school. So if you get anything like bonus points or extra credit, which for me was absolutely unheard of, or unlimited number of attempts, you want to jump on that. So when you go to take the quiz, if you don't get 100 the first time, you miss 1 problem or more, definitely take a look at what was missed, study, and take it again. You have to do this all within the week that it's due. All assignments are due by Sunday night, and you have to take all your attempts before Sunday night. Okay? So everybody should be getting 100 on every single quiz, because you have that opportunity. Give yourself enough time and grab up those points, because when you come to the final exam in week 4, you'll be so glad that you did that for yourself. You'll be sitting there looking at the final exam in a math course, which isn't most people's favorite thing, and you'll have gotten hundreds on all your quizzes. So you're going to feel so much better about what your final grade will come out to be. And leave the points that you miss for actual difficult problems or concepts later in the course, not for, you didn't take an attempt and get 100 like you should have, or these bonus points or something, like you just took it for granted. So it's about managing your time, starting assignments early in the week, and make sure you take the quiz over and over and over until you get 100. That's a piece of advice for me for any course. You should just always get 100. If they offer unlimited number of attempts, that means you get 100 on that assignment. That should be the rule for yourself. Now we have my math lab. We use my math lab, which is a separate optional homework software program, and there's an announcement in our class about how to register for that. So go to the announcement and look for that. this is where you can see the text pages, and I don't think most students even look at the text pages because of how things are these days with classes set up. Even when I taught on ground, it wasn't go to the textbook and look at this chapter. That's an old ancient way of taking a class. But if you want the text pages, they're in my math lab. So it's like a good, I don't know how much it is, but it's a good, it's probably comparable to the textbook. It's such a great resource, and I'll show you what it looks like. When you register into our course, which the announcement will tell you how to do that, this is what it'll look like, our homepage. And on the left side, you'll see assignments here. So you can click on assignments, and when you do that, you'll see week 1 show up. And you can click on that, and this is what it looks like when you click on it. There's a bunch of problems listed. So you can click on any one of these problems and start practicing. And what you do is you read the problem, you put the answer in here and click check answer, and you'll be told right away whether you're understanding or not. And if not, and you need more help, here's the help me solve this button. View an example button, get more help, and this is where you'll see the text pages. And you can go into my math lab, and remember, this is not for a grade. And you can go into this anytime you want and work at any hour and work on any of the problems, parts of them, all of them, go crazy, redo them. If there's a certain concept you're not getting, you can go straight to that type of problem and do that over and over and over until you get it, which I think is just an invaluable resource. So my math lab is really awesome. Much better than just whatever you're doing to get through on the quiz and tests. So now we start with some math concepts. So first we're starting off with decimals. I give you some images to remind you what decimals are. So what you'll be doing is some operations with decimals, like multiplying. So with this problem, 1.839 times 10, what happens is you're taking a number that's a little over 1 and you're multiplying it up by 10. So you're increasing this number. So it's going to become more than 1. And the trick is we're not supposed to use our calculator, so we're supposed to learn these things. And I'm going to also offer YouTube videos. If you go and search like for multiplying decimals on YouTube, you'll find many instructors teaching these things. So you can go and watch and bookmark the ones you like and watch those repetitively. You also have that resource on it, and you can search for any math concept. So what happens when you multiply by 10 is you move the decimal over one place because there's 1 0. It's just sort of a trick or a pattern that we've noticed. It's not a trick. There's really no tricks in math. It's just a pattern that we've noticed. So that's going to equal 18.39. So now we have 1.839 times 100. So there's 2 zeros. So we're going to move the decimal 2 places over. So when you're blowing up a number that's just a little over 1 by 100, it's going to be a bigger number than 1. In fact, it's going to be 183.9. So it shouldn't be a number smaller than 1 in any of these, right? You're multiplying it by a number, a big number. So that's how you do that, and you can guess what the answer is to this. 1.839 times 1,000. So we're going to move the decimal 3 places over because there's 3 zeros. So it's 1839, and that's the answer for that. So remember, you're going to have multiple choice. And so you've got to have good notes next to you with arrows, maybe some words, and always pause this video if you need for anything. So next type of problems I'll cover, this is the types of things that I saw in your quizzes and tests, and this is what you'll see. Change this to a percent or change the percent back to a decimal. So we'll start with 0.28. So remember, a percent means a number out of 100. So we're converting 0.28 to 100 to a number out of 100, but it seems kind of weird, but it's what part of 100 is 28.28 of something. So we're going to have, if we're going to convert it to a percent, we need the percent sign for certain, and 100 has 2 zeros in it, so we're going to move the decimal 2 places to the right, and this makes 28%. So you can play with your calculator, and I highly recommend learning with your calculator. And so you can put 0.28 in there, multiply by 100, and see what you get. It's just in your answer, don't forget the percent sign. If we're to report and the answer is supposed to be changed to a percent, you definitely need this, because 28% is a very different number than just 28. Now for 0.35, we're going to move the decimal over 2 places to the right, so that makes 35%. So you could try the last one, pause the video and try that one. So we have 0.99, and of course we moved the decimal rather over 2 places to the right, and so that's 99%. Now, when going from a percent to a decimal, we recognize that the decimal starts right here, and we're going to go back this way, 2 places. So the answer, sorry, my internet isn't letting me write correctly. This would be 0.44. So it says if the decimal's right here, any number, any whole number has a decimal to the right of it. We just don't write it because it's shorthand. So we recognize it there, and we put the decimal right there, but we need to just put that 0 so it's clear. It's just that 0 there just makes it clear where the decimal is. And then you can try this one. So we recognize that the decimal's right there, move it 2 places to the left, and it's 1.01. You can have that. It doesn't matter what number you're looking at in these, what numbers, it's always just move the decimal 2 places to the right or to the left. Now in this slide, we have rate as a fraction in simplified form. So this is a decimal, 0.015. So what we do is take the significant digits, the 15, and place it over a 100 or 1000 or something. It depends on how many decimal places there are here. And that'll tell you how many zeros should go here. 1, 2, 3. So since there's 3 decimal places here, there should be 3 zeros right here. And then it says in simplified form, so you just got to reduce that. I know it can be reduced because, you know, anything that ends in 5 and 0 is divisible by 5 at least. So I'm going to divide, if I could talk, 15 divided by 5 is 3, and then 1000 divided by 5 is 200, and then I'm looking at 3 over 200 to think if that's reducible or if we can simplify it, but that's it. 3 is pretty much prime, and 3 won't go into 200, so that'll be it. Now we take this next one, 0.123, and we're going to take the significant digits and put it on the numerator, in the numerator of the fraction. In the bottom will go a 10, a 100, or 1000. Depending on how many decimal places we have going on, and there's 3, so again we're going to need a 1000 here. And we have to work to see if that is reducible, and actually that is as far as it'll get, thank goodness, you know, because that'd be a lot of work. And so that's it. Now we take 0.89 and put it in the numerator. 89 goes in the numerator. And since there's 2 places here to the right of the decimal, I'll have 2 zeros. And we just have to work to see if there's any number that will go into each where this is reducible, but that's it. I don't know what kind of problems you'll get, whether they're reducible or not, but you always check to see. Next, add or subtract these decimal numbers. So first of all, what we do with decimal numbers is line these numbers up, line up the decimals. And then we're going to subtract them. So this number is smaller than this number, so this number should go on top. And now, when I taught this in person the first time, I learned that some people learned how to do these from left to right. I learned how to do them from right to left. And when I asked my whole class, Half the class said they learned one way, other half said they learned the other. I thought that was crazy interesting. And that's what's going on in America. So you stick to what you know. I cannot do it left or right. It's just like building a house with my left hand. I'm right-handed to me. So I understand how you would do it from left to right, and it's totally correct. It just makes sure you get the correct answer when you practice these. So I'm going to start on the right. So we want to take 7 from 2. Can't really do that, so we need to make that a 12. And to just make that a 12, we have to borrow from this. The 2 goes down to 1. 12 minus 7 is 5. And then 4 from 1 isn't going to happen, so I need to make that an 11. And so to do that, I need to borrow from the 0. Can't borrow from a 0, so got to make it a 10. I don't know who invented this, but it works. And then you borrow from that, and that's a 9. So 11 minus 4 is 7, and 9 minus 5 is 4, so that's good, but I borrowed, so I need to borrow from here, make that a 9. And so that's a 9. Since I borrowed, this is 0. And I can only do it really fast. It's very hard to do it slow, but I think that's correct with all the borrowing. So the answer is 0.9475. So if you want more of those, definitely go on YouTube and search for subtract decimal numbers. And I've got the same decimal numbers here with adding, and I think this is a little easier. And I would start on the right side. I don't know about anybody if you start on the left. So 7 plus 2 is 9, 4 plus 2 is 6, 5 plus 0 is 5, 0 plus 0 is 0, decimal number goes right here, and 1. And so this is your answer. So if you want more examples of those, definitely go to YouTube and look for instructors teaching those, because you want to really ace these types of problems. Now, this is a problem that I've seen come up. Estimate. Round each number to the nearest hundredth, then calculate. So what we're going to do is take these 3 numbers and round them to the nearest hundred first. Nearest hundred is right here, that place, this place, and this place. And then we're going to add or calculate in the end. So it's like you're going to buy these items in the store and you're going to round up to calculate quickly and easily how much all that'll cost. So what you do when you want to round up to this place is look at the placement, the number to the right of it. If it's 5 or greater, you round up. If not, you just leave it. So this is going to be 590, since that's just a 1. And then 734, we're looking at this 8 to tell us whether to round this 4 up to 5 or not. Since it's 5 or greater, the 8 is a 5 or greater number. That is going to be 735. And then with 125.6, we want to round this digit here up to that digit. So we look to see if this is 5 or greater. It is, and so this needs to be 126. And then you add these, and what I need to do to add them is line them up. If you hear some snoring, it's my little puppy next to me snoring. So 5 plus 6 is 11, carry the 1, 9 plus 3 is 12, 13, 14, 15, carry the 1, 12, 13, 14. So here's your answer. Now we're going to do the same to this line of numbers. We're going to round up to the nearest 100, not hundredth with TH because that's after the decimal, but 100 is up here. So 573, and you can pause the video here and try this one if you want. This has a 2 here, so we wouldn't round that 3 up. So it's 573. And the 103 has this 5 here, which tells us to round up to 104. We're rounding to the nearest 100. And this 9 here tells us to round this 9 up, so that's going to be plus 1,000. And so I'll take this over here and add these this way. So that's 7, 7, 6, 1, so 1677. Next, estimate by rounding to the nearest tenth, or 10. So the tens place is right here, because this is the ones. So we're going to round each number up to this place right here. So the 1 has a 5 next to it. The 5 tells the 1 to go up to 20. So there's 20, like 2 tens. The 91, so this 1 is lower than 5, so that'll just be 90. For this 97, this 7 is greater than 5, so this is going to go up to 100. Can't go to 90, has to be the next one up. And then 55, you have a 5 here, and so that tells this 5 to round up to 60. And then for 47, the 7 tells us to round up to 50. So I don't know if you could add these this way. That's a little challenging for me even. I need it lined up. Much better. So 11 plus 11 is 22. So 320. Now you can pause the video and try this problem and see if you get the same answer that I do. So basically we're estimating by rounding to the nearest 10, and that's this digit here, remember? So this will stay as 30. The next number will be 100. Since that's a 5, that tells the 9 to go up. 11 will stay as a 10. 25 will become a 30. 78 will become an 80. Let me see if I can do this way. 3, 4, 7, 15. I need to line it up. Actually, I'm going to add 30, 30, 60, 70, 70, 100, and 80. So you do it however is best for you. So 250. Now we're going to multiply decimal numbers. Here we have 5.0 times 211, or 2.11. So what I would do is write 2.11 on the top because it has 3 digits. And then you can write 5.0 right here, but anything with a 0 can kind of be hanging out here. Because all I'm going to do is bring down that 0 into the answer and multiply 5 times each digit. Zeros can always be hanging out like that. Bring them down into the answer and then just multiply this digit by each. So 5 times 1, 5 times 1, and 5 times 2. And then you need a decimal somewhere in this answer. So we're going to count how many total decimal places there are. There's 2 here and 1 here, so 3. So you know the decimal goes right here. And you can check yourself with a calculator. So 10.55 might be in the multiple choice, or 10.550. Now for this problem, we don't have a number with the 0 hanging out. But we have 4.91 times 0.25. So the decimals don't need to be lined up, but they happen to look like they are here. But with multiplication, you do not need to line up the decimal numbers. So first thing I do is 5 times each number here. So 5 times 1 is 5, 5 times 9 is 45. Carry the 4. 5 times 4 is 20, plus 4 is 24. 2 times 1 is 2, so I start that line over here. 2 times 9 is 18. Carry the 1. 4 times 2 is 8, plus 1 is 9. Then you have zeros on the bottom, which is insignificant. So now I'm going to add these columns: 5, 7, 12, 11, 12. So here's the answer, but we need decimal somewhere in there. So I count how many total decimal places we have. We have 2 here and 2 here, so that's 4. So a decimal place goes 4 places from the right. And that's the answer. And you could pick up your calculator and just verify that while you're practicing. So if you use your calculator to verify while you're practicing, that's good. Because if you get it incorrect, you'll have to go back and look through your work. And there's nothing wrong with that. Estimate by rounding to the nearest 100. Okay, so remember that the 100 is right here, and right here. So we're looking at 557,000 because the 3 doesn't tell the 7 to go up. But we needed a nearest hundred, so yeah, we do need a place right here. So that digit needs to be here, the 3. So the 3 doesn't go up to 4 because there's just a 4 here. And then this number has a 4 next to it, so it's going to stay as 1. So we're going to multiply this by 100. So 557,300 times 100. So what I'm going to do is, take these zeros, and this is going to be in my answer. They all end up in the answer, and then 1 times each one of these digits. 3, 7, 5, 5. So basically you're taking this number and adding 2 zeros to it. And there's no decimals in this or anything, you just need to check where your commas go. 55 million. And so now we need to round this up to the nearest hundred, which is this number right here, and this up to this number right here. So 778,591, so this needs to go up to a 6. So we'll have 778,600. And then 2 needs to be rounded up because of this 9. So that's 300. And we'll multiply those. So I'm going to write down the 4 zeros. And then 3 times each one of these numbers. 3 times 6 is 18. Carry the 1. 3 times 8 is 24. Oh, so we add the 1 though. I forgot to add the 1. That's up there. So 25, carry the 2. And then 3 times 7 is 21, 22, 23. Carry the 2. So 3 times 7 again is 21, 22, 23. So 23 gets written here. Now we just need to put in our commas. And there you go. Now dividing decimals. See what we've got here? We have 0.0035 divided by 0.35. I really picked problems that you're going to see in your problem bank as far as I saw. So remember, this division sign means like this. This number goes on the outside, and this number goes under. This is something to remember how to do. Draw arrows, write notes in writing for yourself, anything like that. The thing is, this number has to be a whole number in order to divide anything. So we're going to make it a whole number by just moving this decimal. And that'll be 35. And I'm going to rewrite what I do here so we can work on this. When I move this 2 places over, I've got to move this 2 places over. So now we're just looking at 0.35 under here. 35 into 0.35. So what you do is you look at 35 into 0 is 0. Write your decimal. The decimals line up in division as well. 35 doesn't go into 3. Okay, so 0. 35 goes into 35. This is what we do, is look at the whole number as we stretch along. 35 goes into 35 one time. So 0.01 is your answer. And you can put in your calculator this 0.0035 divided by 0.35 equals, and you'll get 0.01. Now to try this next problem, what I'm going to do here is just move this decimal over on down here on this part, so I can just go ahead and write it here because I don't have a lot of room. So this will be 77 on this part of the division bar. Since we moved this 2 places over, we're going to move this 2 places over. So the decimal here should be right here, 0.77. Now I go ahead and divide. You can go ahead and put your decimal right there. They're going to always line up. So this will be a 0. 77 into 0 is just 0. 77 into 7 doesn't work even one time. And then we look at this place value as dividing 77 into 77, and that's one time. So 0.01 again. So I put the same kinds of problems so that you'll really get this pattern down. Now I would pause the video and try this one, and you can guess the answer, but try and do the work. Putting pencil to paper will really help your brain. Okay, so I'm going to move this over 2 places to make it an 89. And so I have to move this 2 places over to make that a 0.89, whatever it comes out to be, because this has to be a whole number. And then the decimal goes right here. So 0 for this, 89 into 8 is 0, 89 into 89 is 1, 0.01. So that's how those work, and I think that's the end of decimals for this week, as far as you'll see. Now we have a section on fractions. And I have a note here to remind myself to tell you, careful in Blackboard when you're looking at problems in your quiz or your test. The division sign is so small it looks like subtraction signs. So you're going to have to blow up your screen. Even if you have glasses, they're so small some students are answering the problem when it's a division problem as if it's a plus maybe or subtraction. And they get it incorrect just because of that. So make sure you remember to always just blow up and look at what the heck that operation symbol is. What we're doing is finding the LCD of these list of fractions. So all we do when we do that is look at the denominators. And we're going to write the LCD here for these. Now the LCD is never going to be your smallest number in your denominator. It's going to be the biggest number or bigger. So 18 is great to use as the LCD if 9 goes into 18, and it does. And so that's it. You're thinking of factors and divisors here. So in this problem, we got a couple fractions here. We got to determine the LCD. We look only at the denominator because that means least common denominator. Now your biggest number is 25, so your LCD will be 25 if 5 does go into 25 evenly. And it does, so 25 will be a good LCD to use. So that's a good start when practicing those. Now you've got one problem maybe you'll see on a quiz or test with each of these, but I'm putting a lot of this so we can practice. So for example here, 1/7 equals what over 21? And you've got to fill in this number. So what we do is think, well, how did we go from 7 to 21? It's 7 times 3. And so 1 times 3 will give us our answer. 1 times 3 is 3. So that's the number that we'd fill in. Now we can go to 7 over 9 equals what over 36. Well, how did they get from 9 to 36? Since they're on the same levels, these are related. So 9 times what is 36? And that's 4. So we have to multiply 7 by the same number. And that'll give us 28 as the missing number. Next, 2 over 5 equals what over 100? And if you want to pause the video and try these at this point, go ahead and do that. And so 5 times what is 100? And that'll be 20. So we have to multiply 2 times 20. That gives us 40, our answer. So 10 times what is 100? And that's 10. So 4 times 10 then is 40, which is our answer. So that's all you do for those. Instead of reducing fractions or simplifying fractions, we're blowing them up, going the opposite direction. Now we're going to simplify the fraction. So first we're given 15 over 21, and we have to simplify the fraction. So what we have to do is find a number that will go and divide into each, if there's anything, evenly. So I'm thinking a 3, and we want the biggest number we can find. So 3 times 7 is the only things that go into 21. 7 doesn't work with 15. So what we take is 21 divided by 3 is 7, and 15 divided by that same 3 is 5. And that's how we reduce the fraction. For this one, you're going to see this as an improper fraction and want to make it a mixed number. I don't care about mixed numbers unless the instructions actually ask us for that. We actually don't see or use mixed numbers anymore. When you get us to a certain point in math courses and up, we just don't use them. There's nothing wrong with an improper fraction. Simplifying an improper fraction is not to make it a mixed number. A mixed number is just a different form. But anyway, we're going to simplify this, and we've got to find a number that goes into each of these. Are you thinking of one? Like 3 goes into each, but I think there's a bigger number than 3 that we could use. If 18 went into each, that'd be great. But I think 9 is going to be the biggest number that goes into each evenly. So 18 divided by 9 is 2, 27 divided by 9 is 3, and that's it. Now for 50 over 90, I'm going to show you a very easy way to reduce or simplify fractions that have those zeros in it. Just cross out the zeros, and there you have your answer. Okay? You just want to make sure 5 over 9 is simplified. So this is going to be 4 over 8, and this can simplify more because each is divisible by 4, so 1 over 2. And this is simply 6 over 7. Can always just cross those zeros out, and that's it. In this problem, we're going to start to add and subtract fractions. Right now, if you notice, the denominators are the same, and that's what we must have in order to add or subtract fractions. So we have 2/5 plus 3/5. That tells you how many parts you're working with, so we have to stay with that many parts. And then with the top, we just add 2 plus 3, which is 5. It's just that 5 over 5 happens to equal 1, and we do simplify that and go ahead and report the 1. Now for this one, we're subtracting 4 sevenths minus 1 seventh, and the denominators stay the same. So the denominator is 7, and then we subtract 4 minus 1, which is 3, and we just make sure that's simplified, and that's it. Next, we're looking at fractions that have denominators that are not alike. So we need to make sure the denominators are alike before we can subtract them. So we find the LCD first. So you find the LCD with fractions only when you're adding and subtracting them, not multiplying and dividing or anything. So if we look at the 9 and 5, we have to think of multiples of 9 and 5 until we have one in common. So 5 doesn't go into 9, so the LCD can't be 9. 9 times 2 is 18. 5 doesn't go into 18. 9 times 3 is 27. 5 doesn't go into 27. 9 times 4 is 36. 5 doesn't go into that. So you have to keep going until basically 9 times 5 is going to work. That'll always be an okay LCD, but maybe it's not always the lowest. But in this case, it's the lowest. So what this tells us is that each denominator needs to become 45. So I'm going to rewrite the problem here so you can just preserve this and see what the original problem was. We need to make each denominator to be 45. So to make this one be 45, we've got to multiply it by 5. To make this denominator be 45, we've got to multiply it by 9. Then what we have to do is do to the top what we do to the bottom. You can't just change a fraction. You have to change the top and the bottom. Then it's actually the same problem. Now I'm going to write what the problem is. So this makes 25 over 45 minus 9 over 45. Now we've got the same kind of problem we've been doing where the bottom has to stay the same, 45, and you're just working with 25 minus 9, which is 16. Now you just make sure this is reduced, and that's it. So now we'll practice a problem in which we have unlike denominators and we're adding. We need to find the LCD. So remember, we have 3 and 9. The LCD is going to be the bigger number or bigger. So 3 does go into 9, and that's great. That means 9's our LCD. So I'm going to rewrite the problem so I can work on it down here. This way when I look back at my work, I can see what the original problem was. Just much more clearly. And so each denominator has to be a 9. This denominator is already a 9, so that one's good. This one needs to be a 9. We have to multiply it by 3, so that'll become a 9. Then we have to do to the top what we do to the bottom. And now I'm going to write what my problem looks like. This will be 3 over 9 plus 5 over 9. Now we have like denominators, and I can determine the answer, 8 over 9. And just as long as that's reduced, that's it. Now multiplying fractions. Alright, so there's 2 ways to do it really. You can multiply fractions straight across and write down what you have and then simplify that in the end, but a lot of times that is a lot of work to simplify. So you can also cross cancel, like does 2 go into 7? No, so those are kind of done. But 3 does go into 18, so you take 3 goes into 3 one time, 3 goes into 18 6 times. And then you can multiply straight across. So 1 times 7 is 7, and then 2 times 6 is 12. And you just check again that that's reduced, and that's it. Now to divide. Dividing is pretty neat because it's really just multiplication. The first thing you need to remember is to change it to multiplication and flip the one on the right. And then we do the same thing. See if we can cross cancel. Well, the 7's cancel. The 5 and the 2's don't. So then you multiply straight across. 1 times 2 is 2, and 5 times 1 is 5. So 2/5 is your answer. Next, what we're doing is changing these fractions to a decimal. So the best way to do that is we have to divide these things in longhand. So you have to remember this division bar like this. The top goes in the bottom, inside there, and this number goes on the side. And so 2 is the same thing as 2.0 or 2.000, and you might need these zeros. And the decimal number is going to go here. I see that I needed to write that as a 20 because 7 doesn't go into 2, so that's a 0 there. So we add the decimal and a 0 so that we're looking at 20. 7 goes into 20 2 times, and you write down 14 because there's going to be leftover. So that's 6 left over. So what we're going to do is add another 0. And we bring down that 0. We're looking at 7 into 60 now. 7 into 60 is 8, is the highest number without going over, so that's 56. And then you have a 4 left over. 7 doesn't go into 4, so you're going to have to make a 0 and bring down that 0 and make that a 40. So 7 times 5 is 35, and that's the closest thing. And now you have a 5 left over. Now, if you keep going, you're going to see this goes on and on for a long time. And bring down another 0 and goes on and on and on. So you have to look in your multiple choice to see what the answer is. But you can put some dots here for yourself to tell you that this goes on and on. You can check with your calculator too. Same thing for this one now. Now this is a decimal number, that's what they wanted, right? So with the division bar, the top number goes under the 5. So the 9 goes on the side there. So 9 doesn't go into 5, so we're going to have to look at that as a 50. Even though that's 5.0, we didn't change the number at all. So 9 goes into 55 times, so that's a 45. Subtract that, and you get another 50 if you add a 0 and bring it down. So that means 5 times 9 is a 45, and you see how this is going to repeat. So it's just, you look in your multiple choice answers and it's 0.55. We can also write that as 0.5 where the 5's repeating, and that's a repeating bar over that. You might see that sometimes. We're coming into the home stretch now. Now we have to write this as a percent. So first you have to write it as a decimal. So the top number goes under, and the 40 goes on the side. So 40 doesn't go into 13, so we need to recognize the decimal and add a 0, so we're looking at 130. So 40 into 130, it looks like it'd be a 3 here because that'd make 120, but we'd have 10 left over. Add a 0, bring it down, so 40 into 100. I guess a 2 would work because that would be 80. And that's a 20 left over. Make a 0, bring it down, so we're looking at 200. 40 times 5 is an even 200, so that's where we'll get a 0 remainder, and we know we can stop. So we got our decimal number that this fraction is equivalent to, 0.325. We just need to convert that to a percent, and we move the decimal 2 places to the right, 32.5%. And that's it. So just a couple more slides of problems. So you'll have problems like this solved. 15 is what percent of 75? Now, I do these a certain way. I've seen students learn a different way. If you know a way or see some YouTube video where an instructor is teaching this and you like it, stick with that way, okay? What I do is translate this word to word. 15 is equals what percent of 75, and of always means multiplication, so those parentheses means multiplication, or I could have put a dot there or a multiplication sign. So I want to find what this x is, and so what I can do is divide both sides by 75, and x will be by itself, x percent. And then I can divide this out, 15 divided by 75, which is 0.2. So all I gotta do is convert 0.2 to percent. So I move the decimal 2 places over, and that's 20%. So the answer for that one is 20%. So let's try this one. It's the same setup. These two different problems are the same setup. So 20 is what percent of 80? So the first thing I want to do is divide that 80 out of there so I can get x by itself. So 20 divided by 80 is 0.25. So what percent is that? If I change that decimal to a percent, that's 25%. So 20 is 25% of 80. Next we have 30 is what percent of 25, and you can pause the video and try this one if you want and see if you get the same answer as I do. So I'm going to translate this. 30 is what percent of 25? And so I'm going to divide 30 by 25. Now if you look, 30 is bigger than 25. How is 30 going to be a part of 25? Well, we're obviously going to get an answer 100 and something, over 100%. But let's just work it out and see. So when you divide out 30 divided by 25, is 1.2. So I need to convert 1.2 2% by moving that decimal 2 places to the right. So that's 100. Well, I messed it up. So that's 120%. The other type of problem like that you'll see is this. What is 10% of 75? So I translate that left to right. Other people do this fraction is over of thing, which is totally fine, and you might like that, so stick with what you like and is working. So I do it this way. What is equals 10% of 75. And then it's very easy because when we use percent in calculation, we have to write the decimal of it. And we usually don't write this multiplication sign anymore. We use parentheses or a dot. So I'll just write parentheses. And I just have to figure out what 0.1 times 75 is, which is 7.5. And so that's the answer. So we'll do this one. What is 15% of 75? So what is 15% of 75? And I've got to convert 15 to a 0.15 to use it in calculation. So you do this a lot in real world. You do this in your mortgages and loans to figure out things. And so then we multiply 0.15 times 75. That's 11.25. So that's your answer. So you can try this one and pause the video and try it if you want. Otherwise, I'm going to translate it. What is 30% of 75? So I've got to change that 30% to 0.30 times 75. And so that'll be 22.5. And that's it. I hope that helped you this week. Don't forget, by Sunday night, what is due is a certification, a pre-test, a quiz, and a test for this week. Use my math lab and YouTube. Also, khanacademy.org is students' favorites for help. And don't forget those division signs. Blow up your screen, get it like zoom in so you can see what symbol you're actually looking at in your problems. And good luck this week.